I'm Paula Hong, a Senior Applications Chemist at Waters Corporation. I work in the separations laboratory, testing new technologies and talking with chemists about the challenges you face using analytical instruments. Today I want to tell you about some of the work we've done with a common analytical problem. In any analytical method, we have to both detect and quantify all the important components. However, we frequently encounter mixtures where those important analytes do not share common detectability. At Waters, we have been working to combine orthogonal detectors so that we can measure such compounds with different properties. Let me show you an example of a sample that includes both UV absorbing and UV transparent analytes. To assay such a sample, it's common to run it using multiple methods. What we are considering here is how to successfully combine two different detectors so that all the components may be measured in a single run. We'll use an ACQUITY QDA mass detector to extend the sample coverage that is possible with the UV detector. For this approach to be successful, we also use the split and dilute capabilities that are provided with the restrictor modules of the ACQUITY Isocratic Solvent Manager. Let's look at the data. As you can see in this chromatogram, one of the compounds gets a large single peak in the mass detector channel, while the other component gives a single peak in the UV. By using the mass detector in parallel with UV, we can find and measure an analyte that would not have been apparent if we had only used the UV detector. Both channels can be processed within a single method in Empower 3 software. The response for both compounds using the two orthogonal detectors is linear and suitable for quantitative analysis of the mixture. When we run a sample, we can compare the areas for both channels to get a quantitative measure of the contents of the sample. You may also have noticed in the UV channel that there is a small peak that elutes after the main component. With our combined detectors, we can examine that peak in more detail, as shown here in the mass analysis window in Empower 3 software. We can see that both the mass and UV spectrum of the component are different, and those spectral data provide a starting point in the identification of this impurity. So what we've been looking at is the way we assemble the system and the way we process the data in approaching the complete and quantitative analysis of all the components of the sample. For additional information, please go to waters.com/QDA. I'm Paula Hong for Waters Corporation. Thank you.